Hello and welcome to this video. In this video, we are going to solve Browser Navigation System LLD. This was asked in BrowserStack. So now let's move to the problem statement. So we are required to simulate the link navigation of a browser. What actions that this system should support? There are some methods given in the problem statement. First method is visit URL. When we provide a URL string inside visit method, then our browse navigation system should visit this URL. This clears any forward history as well. That means if we are visiting a new URL, then we should not able to move forward apart from this URL. Second method that we need to create is back. We should able to go back to previously visited page. If there is no previous page, stay on the current page. So let's say when we visited our first page, and after that we will call the back method. Because we have only visited one page, then we should not able to perform the back operation. In this case, we should stay on the current page. Now we need to create a forward method as well. Go forward to the next page if a back operation was done. So if we have completed a back operation, then we should be able to perform the forward operation on our page. And the fourth method is getCurrentPage. Return the current URL being viewed. Now let's move to the input format. So in this, we need to implement a class BrowserHistory with the following methods. So these are all the methods. One is the BrowserHistory. This is nothing. This is just a overloaded constructor. Then we will have visit method, which will take an input parameter as string. Then we will have back, forward. These will not take any input parameters. Back will just go step 1. Forward will go step forward. Back will do step backward. Step backward. Forward will do step forward. And get current page, on current page simply returns this URL. Let's say we have visited google.com, and if we call this current page, then it should return google.com. What should be the behavior? Visiting a new page pushes it onto the history and clears the forward stack. Back and forward move the pointer through the history accordingly. Constraint: URL are non-empty lowercase string. So we cannot pass non-empty string. We cannot pass empty string in the URL. No more than 10 to the power 4 operation will be performed. So this is an example that we can perform. This is how our class will look like. This is our demo class, how it will look like. We will create an object of browser history class. Then we can call the object using .visit method. Initially, when this is going to be our home page, youtube.com. After that, we will visit the google.com. So how it will work, let's see. When we created the new object of browser history, we have the, let me create this. This is the our youtube.com. Okay. After this is our current. This will be our current page. Okay. After that, we will visit google.com. So from here we will move toward this, right? And now our current will move from this. Current. Now this will point to current. And at this point we will again move to github.com. So from here we move to here. Now our current, let me erase this. Now our current will move to here. So if you see, we have started from here. So these are the operations we have done. This one we already started with YouTube. We have visited google.com. We have visited github.com. Correct? These three steps we already performed. Now we need to move backward. Now this should return google.com. So what we need to do is we need to go backward from here. Correct? With this, our current pointer should also move to here. Here, this should move. Now if you see, now this step we have completed, and now our current is pointing to Google. If we call forward, now we can call forward because we have already visited Google and performed our first back operation. So now it will again, now let me point it with red. It will again go forward and our current will move with that. Right, this is forward operation we also perform. Now we need to visit a new link. Let me move this current. Let me move this current to here and remove this. Now we need to move to linkedin.com. Correct? So I will create another box here. LinkedIn. Here we have moved. Now our current pointer should also point this, and it should get removed from this one. Correct? So this step is also completed here. Now if we do forward, we do not have any other option here. If you see, there is no forward here. It is empty. So it will return this LinkedIn only if we call the forward. Now if we call the backward, what should we get? We should able to go on github.com and our current pointer should move here, right? So now let's think about it. These type of LLD problems are actually We do not need to create a multiple classes to solve these kind of problems, because here in the question itself we are asked to design only a single class which has certain methods. So these type of questions certainly required to implement the logic only, and which requires certain kinds of data structures. We need to identify a data structure that should fulfill this condition, where we can uh, where we can store the URLs and also store the forward and backward positions. So if we see, there are multiple options, like we need to take a current pointer as well. What we can do is, what so we need to have three things. One is URL that we need to maintain. Apart from that, a forward direction we need to move, pointer we can see, and backward pointer. So when we say forward or backward pointers, the first thought that will come into our mind is a linked list which will have a next, right? But because we need forward and backward, which thing will come into mind? A doubly linked list that will have a back pointer. If I try to create it, it will have a URL and node back and node forward, something like that. This will solve our problem, right? And node current. For maintaining the current position of the node. So in this case, in this implementation, we need to define a doubly linked list. And a doubly linked list current node, with the help of that, when we whenever we visit a certain URL or website, then we will try to create a new node. We will create a new node every time that will have forward and backward thing, and we will try to associate. We will create a new node whenever we visits, and it will have a current node. If we already have like previous page, then we should point this new node to current.next. This should point, right? That should be our implementation, how we can go back. So when we need to go back, what we need to check? If current.previous, right? If current dot is exist or not. If current.previous exists, then we can go backward, right? If current.forward exists, then we can go forward. If it does not exist, then wherever we are, we just need to return the current page. I think that is how we are going to solve this problem. There are multiple ways. Like when I read this question, I thought about this, that we need to move forward and backward. In that case, we can use a doubly linked list, but there are multiple things that we can use as well. There can be a array list that we can use, fixed array list, or array where we can mention where we can maintain a current index as well. This will solve our problem, right? When we move forward or backward. There are also there is one more option that we can use to doubly. There are like two stacks that we can use. One is for back stack, one is for forward stack. But because this implementation is does not require a fixed size array, we can scale it, we can have any size. And in stack we need to maintain two data structures, one for forward, moving forward, one for backward, and we need to remove and add element there. So for this scenario, the double linked list fits best. Now let's move to the solution. So we will have a browser history class. Here we are creating a history node, and here we have our browser history methods: visit method, back method, forward method, and get current page. Now let's see the history node. So this is our linked list. This is our doubly linked list where we have defined a string URL and a previous and next node, or we can say forward or backward. So here we have a constructor where we are passing a URL. So here it will define the URL, and previous and next will remain null when we call the history node URL constructor. Now let's see the browser history class. In this class, we are maintaining a current history node as well. So when we are defining our browser history, we are just marking this.current to new history node. And home page we are passing inside it. So this will become the URL of this page, and it does not have any previous or next pointers, correct? So now let's see, when we visits a new page, what will happen? We will create a new node. Now this new node will have empty previous and next values. They are not attached to anything. They are not pointing to anything. So what we will do is, if current exists, then what we need to do is current.next, we need to define this to new node, and new node dot previous, we need to assign it to current. So we are linking here, link the new node after current node. Okay, and then after the linking is done, what we need to do is we just define current is equals to new node. Now new node dot previous will have current, and current will have new node. So this way we will start linking our implementation. So if you see, when we have YouTube, there is no required for linkage, but when we get Google, right? In that case, what we need to do is it will have its previous as null and forward as next as null, right? When we will define our new node as Google. So previous we should give its address, right? YouTube. That is what we are doing here. New node dot previous is equals to current. This is what we are doing. Current dot next is equals to new node. Here we have linked it, and then current, we are moving our pointer whenever we are creating a new node, right? So that's how the implementation. In for back operation, what we need to do is we need to check if current dot previous is not equal to null. This should be the condition. If it is null, then we just need to run the current URL. In that case, we just need to point it to previous one, current dot previous. Now it will have the previous node. Current will become its previous node, and current pointer will move backwards, and current URL, then we can return it. Similarly, in same, we will check the current dot next in case of forward. So same implementation here we do current is equal to, and then we will return the current URL. For get current page, it's very simple. We are just returning the current URL. Nothing fancy here. Now let's see the demo. Let me run the demo class. So here if you see, we are on initial page. We are printing current page youtube.com when we define our object. Then we are visiting the Google and we are printing the current page. So Google, GitHub, these two things. Then we are storing the back result. What it should return. It should return the current URL, back URL. So that after back we are printing, we got the from GitHub to Google we got. So Google we got. Here we are printing back result, current, get current page. After forward, we should again go back to github.com. So this is what happened. After visiting linkedin.com, now see, we are again visiting. So it clears forward history. After visiting LinkedIn, we are on current page. Now we are again doing forward. But because there is no forward history on linkedin.com, we will get the same result. You see, after visiting linkedin.com, after forward, no forward history, linkedin.com, we get the current result. Again, we can do back. That's how we do. So I think this question is basically based on the how we are going to define our class and which data structure we can use. So there are 2-3 ways which we can use. As I explained, one is doubly linked list, other we can use is two stack, one is for forward and backward stack, and then there is another way to use a array, fixed size array or array list and maintain the current index. I hope you like this video. Please like this video, subscribe my channel for more such content. Thank you.